Alright, good afternoon everyone. Clock strikes 12. We're going to start with our Sec 4 E-Math lesson for today with teacher Jason over here. Alright, forgot to introduce myself. Alright, so along the way, just remember to be patient and understanding, observe gracious and respectful behavior, even in digital space or when you're typing, and lastly, ask good and relevant questions for today. Okay, so what are we going to venture in? So today is going to be the introduction of a new topic known as vectors. So again, with something new, you have to know what is a vector and how we represent it, and how you're going to see it on the Cartesian plane. So xy axis, and then some other things that we can take note of. So how long a vector is, what does it mean to be equal vectors and zero vectors. Alright, so let's get started. Okay, so let's investigate. Suppose, let's say, Jane walks a distance of 2 km from home to school in the morning. So when Jane walks home from school along the same route, so what happens is from home to school is 2 km. So this distance over here is 2 km. However, when Jane walks home from school along the same route, okay, the distance, does it change? It doesn't, right? Okay, because it's the same distance that we are looking at. And we realize it's also, in this case, the notion of, in this case, 2 km. Alright, it's also 2 km. Okay, so what does it mean? You realize we take note the quantity remains unchanged despite the change in direction. So one of it is going from left to right, one of it is going from right to left, but however, we realize the direction does not change. So what does it mean over here? And in this case, if you were to zoom in even more, what is the difference between the distance and displacement? Okay, so if you realize, if I were to take note of just distance, walking 2 km to school, just 2 km, take note of the words over here, 2 km. Okay, you realize over here, I'm just talking about, in this case, the magnitude. So that's the notion over here. I'm just talking about the magnitude. Okay, so over here, time to listen to the explanation, very important. Okay, then afterwards you realize, when I talk about displacement, now for those who are unclear with north, south, east and west, so north, south, south is not here, south, east and west, alright, this is the notion over here. So the difference between displacement and distance is that there is something over here I need to consider. Now, what is that something? Does anybody want to try? So just highlighting over here, let me do the same color coding. So over here, the 2 km and then the east mentions over here. So one of them is what we call the magnitude. So the east over here, does anybody else wants to try? What's the distinctive thing that I am looking over here when I'm saying is traveling east? What's this distinctive thing over here? Alright, very good. Okay, some of you all got the answer already. You realize we are talking about the direction. So what does it mean over here when I talk about magnitude and direction? Okay, so when we come to this, you realize there are two different things we are taking note of. One with magnitude, the other with magnitude and direction. So therefore, what we are talking about is that there are two types of quantities that we need to take note of. One of them is what we call a scalar quantity, and one is what we call a vector quantity. And vector, take note, very two important things here to take note. Vector has to have both magnitude and direction. Okay, so a scalar quantity, what we have mentioned just now, one example, distance, and in this case over here, displacement. Now, does anybody want to give it another try? What would be an example of a scalar quantity and a vector quantity? Does anybody else wants to give it a try? What's the difference? What is one more consideration that I can take note of? Let me bring it down to the floor for a while. Okay, let's give it a try. Let's think about it. Let's think this together. What will be a scalar quantity and a vector quantity I can take note of? Okay, let me give a hint over here. It's something you've learned in Sec 1. Something got to do with rate. Alright, give you some time. Alright, very good. Alright. Size, I would say size is a scalar quantity. That's a good try, Jude. That's a good try. Alright. That's a good try, but that's correct actually. That's correct. But in this case, for vector quantity, for size is a little bit hard to sense. Alright, but I guess let me bring it down to the floor and give one example. So scalar quantity, we can talk about speed and velocity. So velocity, remember there's a certain direction we can look at for those who took physics. For those who doesn't, just remember velocity is basically speed in direction. Right, so that's basically two particular things that we can take note of. And in fact, there's actually one more example to how we can take note. So, bubble question number 1, just to get you familiarized. Is mass a scalar or vector quantity? So this one should be quite quick, 30 seconds, launching it in 3, 2, 1, let's go. Alright, shouldn't take too long. Alright, very nice. Okay, most of you got it. Okay, is it a scalar or a vector quantity? Take note, there are only two options. Don't click 3 and 4. If you click 3 and 4, it'll be wrong, because there's no particular option as such. Alright, I'll just wait a while more. That's good, that's good. Okay, most of you got it. Okay, so I just wait for the counter while I explain. So in this case, yes, most of you got it. In fact, all of you got it. That's a good sign. Okay, so what is a mass? In this case, let's have an example. John has a mass of 100 kilos. Now 100 kilos over here, the notion is that I'm telling you how much it is, so the magnitude. But there's no direction. I'm not saying 100 kilos east, 100 kilos west. I mean, it doesn't make sense to say that. So therefore, answer is scalar. Alright, so this one quite straightforward. Let's move on to the next one. Now we talk about acceleration. Let's try. Let's bring it down to the floor. Is it a scalar or is it a vector? Right, launching the bubble launcher in 3, 2, 1, let's go. Alright, let's see how we got it. Alright, perfect. Alright, most of you got it. Acceleration. So when I'm talking about acceleration over here, is it scalar or is it a vector? Alright, very good. Alright, so in this case, instead of guess and check, let's see. Okay, most of you got the response. Very good. So, again, let me go down to explanation since most of you got it. So what is a good example over here? Okay, I'm not really an artist, but let's say suppose I have a car. Okay, my car is not very nice, so just bear with me. So this is a car, okay, with 4 wheels. Let me just draw it, finish. 1, 2, 3, 4. Okay, bear with my drawing, it's not very nice, I understand. Okay, let's say this is a car, and what happens, let's say a car is moving forward. Now, let's say if I want the car to speed up, it has to accelerate in the same direction, alright? Accelerate in the same direction. So that means the car, when it moves forward, it moves at a velocity this way. And in this case, it accelerates this way. So in order for the car to actually move faster, this is to speed up. Okay, this is for the car to speed up. Okay, this is just one example. Alright, but now when I want the car to slow down, let's say it's traveling this way, right? That's the speed. Velocity has direction. Okay, if I want the car to slow down, it has to accelerate in the other manner. Let's say I need to change direction because it has to slow down to change direction. So therefore, I'm sort of accelerating in the other way. So therefore, acceleration actually goes to the left in order for me to slow down. Okay, so that is why my acceleration has direction, because it has to counteract in order for the car to slow down and move this way. So the speed up, what happens, you can picture the car is moving this way, and the slow down, what happens, the car wants to move the other way. So it is sort of accelerating slow, it wants to accelerate this way, so it both counteract, slows down, and it forces it to go this way. Okay, so along the way in that manner. But most of you got it, it is a vector quantity. Right, so it's just an identification of what is a vector quantity and what is a scalar quantity. Okay, if it's still not clear, you can let me know at the end of the lesson. I'll be more than happy to answer any of your queries. But then again, you guys are doing good. You guys are doing so awesome right here. So awesome right here. Alright, just keep it up. Alright, just keep it up. Okay, you guys are doing so good. Okay, now, what does it mean to represent as a vector? We have talked about what is a scalar, what a vector means, magnitude and direction. How do we represent it? Now, when we represent a vector, take note. In order to represent the magnitude and direction, it has to follow this notion called a directed line segment. Okay, as you have known, why a directed line segment over here? Because when I draw the line, it has to have a certain length, right? So the length of the line in this case represent, in this case, the magnitude, and the arrow on the line over here represents the direction. That's the main thing over here. So to represent the magnitude, it's the length of the line segment. To represent the direction, it's the arrow on the line. Alright, so to emphasize, this is the direction over here. And to represent how long it is my, sorry, wrong color. Let me try again. It represents my magnitude. Alright, I hope you guys are getting it, okay, so far with regards to how we represent a vector. So in this case, to actually get some feedback, okay, over here, let me just initiate a feedback over here to see how you guys are getting it. Okay, so I hope you guys are getting it. So just make sure if you understand, just click your responses. Alright. Okay, for the red one, if you don't understand at all, at the end of the lesson there's a Q&A, feel free to ask me ahead. Alright. Okay, that's good. I just have one more response, but I'm glad you guys are understanding it. That's good to hear. For the one that clicked red, just make sure that just type it out so that I can understand what you don't understand. Okay? Alright. Now, to represent a vector, what happens is we can represent it along as a bolded. Okay, but this is usually how the textbooks or how the questions represent, because they don't expect you to bold your words and circle like this much. No, they don't expect you to bold it this way. Okay, this is actually to do a writing, it's not understanding. So more or less how they will ask you to write it is either they will ask you to write the vector itself, in this case the vector A, B. So it goes A to B with the arrow indicating the direction of the line that it goes, or in this case the letter A but with the curly sign. So to represent it over here, vector A with the curly sign, where in this case, if let's say you represent as AB, what happens is the representation will be A over here, it's the starting, or in this case I call it the, in this case, initial point, and B over here is what we call the ending or terminal point. Okay, starting, ending, initial, terminal, we can change the words intermediately. It's what the name suggests over here. A is the starting point, you read the arrow A to B. That's how I read it. A to B, that is the notion over here. Alright, so this is how we represent a vector even further. Okay, all good? Okay, I hope that you guys are getting this, because to understand the vectors, you have to get the terminologies first. Okay, now let's see whether we can get the understanding over here. Which option shows the correct representation of the given vector P? So P is this vector here. How would I represent it? Okay, remember the arrows denote the start and end. Okay, so from one to the other. Alright, 30 seconds, not too long. Launching the bubble in 3, 2, 1, and let's go. Okay, let's see the responses that I have. I hope it's good. Alright, perfect. You guys are getting it so well, so good. So P, so the vector P, how do I represent it? Okay, last 15 seconds. Alright, doing well, doing good. Alright, so along the way, if you're not sure, just write down the questions. Alright, last 4 seconds. Give it a shot. Alright, okay. For those who have answered, you've got it good. For the one that have not answered, let me just go through for the benefit of doubt. So in this case, you realize my arrow goes from P to Q. So you, in this case, the starting point, it's over here, and the ending point, it's over here. So P to Q. Take note of the arrows over here, okay? In this case, it goes from P to Q. So therefore, in this case, okay, it has to go from P to Q. Therefore, this is the answer, because my starting point is at P. And my ending point is at Q. So there's just one thing for you to take note, alright? Starting point at P, ending point at Q. Okay, so that's why 1 is my answer over here. So remember, correct representation is very, very important, because when we follow up from there, it's quite crucial in terms of getting the calculations. Now, all we have been talking about is the representation. But how do we represent it in numbers? So in vectors, we can represent it as what we call a column vector. Now, what is a column? Let me test you all. Okay, suppose I have this and this. Okay, Okay, let's label this as A, label this as B. Which one is my column vector? Right? Write down your number, A or B. Give it a try. Just write alphabet A or B. Alright, very good, Ian. Very good, Jude. Anybody else wants to try? Okay, is it A or B? Okay, very good, Ian and Jude. You're getting correct. So whenever I want to represent it as a column, let's just recall. What do we have? Alright, but seems like you all got it. That's actually correct. Good job, Ian. Good job, Jude. Okay, so if you were to follow very closely from the notion of my matrices, when I talk about column, it's actually written this way, and we represent it usually in the two alphabets, in this case X and Y. Where in this case the top X over here, we talk about the movement in my X-axis. So X represents along the X-axis, number of units, and in this case the other one, my Y over here, represents the Y-axis. Alright, Y-axis, along the Y-axis. So this is my X, this is my Y. Alright, so this is the representation. And to further understand even more how we represent it on the Cartesian plane, okay, take a look at this video as where I will pause along the way to actually illustrate certain information. Alright, so let me just start this. So column vectors, how do we represent them? Okay, suppose a point A to point B. Okay, let's say I want to draw the vector up this way. Now, two things to take note. If I were to move to the right, 5 units, in this case to the right, if you were to picture the x-axis, because it's rightward, okay? If you were to picture my axis, y-axis, x-axis. Let me just draw by the side so you all can refer. Okay, so y-axis, x-axis, and 0. Because it's to the right and it's to the positive side. Yep, that's right. Vertical is below, like translation. You can remember it that way. Yep, that's the notion over here. Very good job, Ian. Alright, so if you were to picture horizontal translation refers to the rightward, positive. Upward, if you refer to the y-axis, it's positive as well. Okay, following, in this case, if you were to refer to following the x-axis, x and y-axis as to the Cartesian plane. Alright, so just follow from there as such. And then from there, you try to picture for the rest of the vectors that are drawn out, A to C. Now, in this case, vertical is below and up, as what Ian has mentioned. A to C now is to the left. Now, in this case, 5 units, but the direction says to the left. That's why negative, as we actually picture over here. Left side of the x-axis is negative. So that's where we go from. And you will see from there. Negative 5 and 3, carry on. Yep, upward as well. Now, what happens if, let's say, my vector green part actually goes down? Again, example A, D. Following from there, similar notion. Okay, following from there. Alright, next few parts is just to get to understand how you absorb the notion over there. So you'll be able to see clearly how it works. Alright, so don't worry. Okay, downwards as such. Okay, so that is how we do downwards following the x-axis. Alright, okay. Is that all? Yep, that's all from here. So you realize what happens? It is essentially following how the axis works. Upwards is positive, downwards is negative for my y. Right side is x, right side is positive, left side is negative, just like my x-axis. Alright, so following the very, very, very relevant and I would say equivalent notion for x and y axis in the Cartesian plane. Okay, so I hope this is clear. Okay, let me just initiate a feedback again to make sure that you guys understand before I actually move on. Okay. Alright, okay, good to hear that you all understand from there. That's good. Okay, for the rest, okay, yes. Let me just wait. Okay, so seems like there's a little bit of green and yellow. That's a good sign over there to hear. Right, that's a good sign to hear. Alright, that's good. Awesome, perfect. So all the yellow and green. That's a good sign over there. Alright, so along the way again, if it's not clear, just type down. I'll be more than happy to help. Alright, so I can move on. Now, how do I write my column vector? So A, B. So how do I read it? Let me just try and help you all from here. So A, B. So let's just see. You realize A, to get from A, B, this part, let me just do a highlighting. A to B. It moves from 5 to -2 before it stops vertically enough for it to move up from 0 to 4. So AB, take note in this case. 5 to negative 2 tells me it moves to the right by 3. And 0 to 4 tells me it moves upwards by 4. So therefore, AB, my column vector, I hope your C is represented by 3, 4, as indicated by the red and blue notion over here. Alright, now I want to give it a try over here. Very good in this case. Alright. It's not 4 4 Jude, okay, but you are getting there because from negative 5 to negative 2. Alright, negative 5 to negative 2. But I think you got the notion over there. Just a little calculation error. The signs are correct, that's why it matters from there. Right now, let me just bring it to the floor. Let's try CD. So CD, what is my vector? I'll give you all a try. CD. What is the vector that I want to represent? Okay, for the rest to try. What is CD? Okay, so CD, take note, in this case, let me give some pointers. It moves, in this case, to the left and up this way. So let me just do the arrows. In this case, A is right, up. CD is left, up. So what do I have? Anybody else wants to try? What do I have? Right, very good. Okay, I think you guys got it. Because what happens is C moves from the right 5 to 1. So it's moving left. So take note, left is negative by 4 units. And in this case, moving up, it's going to be positive. Alright, so that's where the notion is for negative 4 and 2. Alright, last one, EF. You realize in this case there is no up, but it's just in this case moving right. So in this case, I hope it is clear that if I move from right, from negative 2 to 3, it's 5 units long, 5 units. But is there going to be anything at my vertical? Is there going to be anything at my vertical? Okay, is there going to be anything for my vertical? Yes or no? Just type a response. Is it going to be anything from the vertical? Okay, you realize there's nothing, right? Because I'm not moving up, not moving down. It's stuck at the origin. Alright, so most of you got it. So that's why in this case, it's going to be a 5, 0. Whereby in this case, there's only a 5. Okay, in fact, I should use the same color coding. Let me just erase this. Okay, let me just erase this. Okay, let me just use the same one, same color, to sort of get the response. So it's 5, 0. And in this case, 0 because there's no up and down. Alright, so I hope you all got it from there. Okay, so that's that. And let's try to see how you all fare for my vectors. So I'm now looking at WX. Alright, WX. Okay, so give it some time. I'll give you some time to read it through. Launching the bubble launcher in 3, 2, 1, let's go. Alright, let's see what we have. Okay, give it some time. I only want WX, guys. WX. So in this case, this vector over here. Alright, so give it a response. What will I have? Alright, very good. That's good to see. So read it very carefully. Again, I'm moving up. So what moving up means? Okay, I'm moving up. Moving up. Okay, there's 30 more seconds. Give it a shot. Okay, just remember, doing good, doing well. Always remember that you guys are always awesome. Awesome in terms of able to follow my flow. Alright, but if it's not clear, just let me know. Alright, just let me know. Alright, last 10 seconds. Last 5, 3, 2, 1. Alright, that's good. Let me see the response that I have. Alright, perfect. Okay, all good. So I believe you all know the answer in this case is 0, 6 because I am moving up. Okay, let me just use the notion. In this case, it's only up. There's no right, left, so 0. Okay, let's move on. In this case, I think I have one more. Yep, that's right. The harder one. YZ. Okay, take note of the arrow notation. Launching the bubble launcher, sorry for the tongue twister, in 3, 2, 1, let's go. Right, let's see what we have over here. Give it some time. Take note, I'm looking at YZ now. YZ. Okay, very good. Okay, just be careful. Okay, YZ. I'm basically looking at. Okay, Let y'all try. Okay, but in this case, maybe because it's hard to read, I'm looking at Y and Z. Alright, just remember, if you want to see, draw a triangle. It will help you. Alright, doing good, doing well. Okay, just 20 more seconds. Okay, that's good. Okay, so I believe most of you got it. I think I can take the time to go through. If there's no, there's no technical here. So in this case, if you take note, 4 to 2, this is 6. Okay, let me just write the units first, 6 and 7. But one is going left and down. So we call going left, it's a minus sign. Going down, it's a minus sign as well. Henceforth, 6, 7. Okay, just take note. One is going left, one is going down. Okay, so this is going left, and this is going down. Right, left and down. That's one thing to take note over here. Right, but so far you guys are doing good, doing well. Let's move on. Right, so what happens right now? I have a few points labeled for me. Okay, so first one. There are first set of questions, draw and label the vector ST. Now what happens is S is given to you but T is not given. So we have to visualize. 3 units means what? 3 units to the right. So therefore, moving from -2 to the right is going to be 2, 1 unit, 2 unit, 3 units. So the first part means I'm going to move to 1. Now, -4. Take note. In this case, let me test you all again. -4. Am I going to go in this way? Let's label as A, or this way, label as B. Okay, let me just get the feedback. A or B? What will be the response? Do I go A side or B side? Okay, it's like A or B for me, guys. A or B? Alright, very good, Jude. That's correct. Anybody else wants to try? A or B? Okay, it seems like you guys got it. Alright, perfect. Good. Okay, you guys are getting it. You guys are rocking this. Alright. So what happens is, in this case, you realize we are going down because it's negative. So therefore, we are going down as such. So 4, take note, I'm going 4. Negative already tells me it goes down. But what about it? So 4 down. 4 down, sorry. So 4 units down. 1. Again, different color coding. 1, 2, 3, and 4. So therefore, my point T, I hope you all realize, is going to be here. Alright, all you need to do, remember to draw a straight line down. This manner. Okay? With my arrow. Arrows are very important. Alright? Now, in this case, U, -2, 5. Now, it is not always the case whereby the starting point is given to you. So what happens is -2, 5, a reference. It just has to be a vector that goes 2 units left, 5 units up. So in this case, you can draw it here, but for reference, I will just draw it according to where I want it to be. So -2 units left. So what does it mean? Okay, suppose let's say U is here. Let's say U is here. Okay, I want to go -2 units. So it's going to be, follow the color coding. 2, it's this way. Okay, -2, again to the left. Okay, again, this is right down. Let me just emphasize. And again, 5 units is going to go up, right? Follow the notion. So 1. So in this case, 1, 2, 3, 4, 5. So 5 units up. And henceforth, UV is this way. Now, of course, you may wonder, teacher, if my point U and V is unknown, can I draw it elsewhere in the grid? Yes, because all in all, what we want to do is just we want to get the direction such that my vector in this case actually goes 2 units left, 5 units up. So in this case, let's say I start from here. 2 units left, 5 units up. It's also okay to have my vector over here. Alright, UV can be this also. Okay, you realize it's the same vector. What do they mean? Stay tuned for the following lessons to come. Alright, but I hope you guys are understanding this part and you will need further practice like this to do on your own with point given and the other one that is not given to you. Alright, so in this case, I think you guys are shy, so let me initiate the feedback again to see where we guys are at this point in time before I move on. Okay, there's some understanding. So okay, so it's half. Okay, along the way, yes, okay, so I have 1 at the red side. Again, the red side, if you're not clear, feel free to type it down so that I can help you along. Alright, I can help you along. But more or less, what happens, this concept is saying, okay, I am giving you a point. How would I draw? Say for example 3, -4. 3 positive means to the right, -4 means 4 units down. And then we can repeat from there. Alright, but again, there's a little Q&A along the way. If it's not clear, just ask me ahead later on. Alright, now moving on. Let's investigate. So somewhere you see right angle triangle. What is that particular theorem that we use? I'll give you some time to think about it. What is the theorem that we use, that we actually use to find this length over here? Okay, very good, Jude. That's actually the answer. Anyway, the famous mathematician that you hear in Sec 2. So once you hear this, immediately you see right angle triangle. You will always write this first thing over here, which is saying using Pythagoras theorem. Using Pythagoras theorem. So Pythagoras theorem tells me what? Okay, if I want to find the diagonal, it's a square equals to, in this case, b square plus c square. Okay, which is in this case 3 square plus, sorry, not 3 square. Okay, AC. So it's going to be 4 square plus 3 square. So 4 square plus 3 square, this is 25. Now in this case, usually you all will say square root must have plus minus, but because this is a length, therefore there is no plus minus. It's just positive, alright? So therefore I take square root of 25, AB is 5 cm. Now you may wonder, what is the purpose of this investigation? Isn't this something we have learned in Sec 2? So what is the purpose of this? If you were to recall how I were to determine my vector x and y, right? It is always going to form a right angle triangle. Okay, let me just backtrack a bit. It is always going to form a right angle triangle. XY, XY. It's always going to form a right angle triangle. So therefore, what we are doing here, the length of the line segment is essentially using Pythagoras theorem. What we have done so far. And there are two notations for it. Alright. One is what we call taking the two lines, okay, this is what we call the absolute value sign and the vector involved. And the other way where we write it is also, again, absolute value, okay, just note it by these two lines over here. And we say just the letter itself. Alright, because you realize, take note, magnitude is just one value, it doesn't tell you the direction. One example of a scalar quantity as well. Okay, so how do we apply the magnitude of a vector? If we were to take a look at this, AB is in A, where in this case XY, if you follow a notation, X over here in this case is this particular notion over here. This is my X, and in this case, my Y is over here. So XY, if you follow Pythagoras theorem, essentially is telling me x squared plus y squared. So this is the magnitude of the vector that I have. Okay, now, following, how do we apply? Okay, before I go on, let me just initiate again. I understand that this is a little tough. Okay, so let's see how you all will fare from here. So I hope you all understand. Okay, that's good to see. Okay, for the rest, just give me my response before I move on to some work examples. Alright, that's good to hear. That's good to hear. I don't really have any yellows. That's good. Okay. But in fact, there's a red. Okay, so for the one who has been clicking red, just let me know during the Q&A, alright, whether you need further help. Alright. Alright, but seems like the response is doing good. Let's move on. So if you realize these vectors, I'm going to reuse it for work example 1. So let's see how we find the magnitude of these vectors. Okay, now AB, if you recall, AB, my vector is actually 3, 4. So how do we calculate the magnitude? Pythagoras theorem. Or in fact, by Pythagoras, we just have to do this over here is my x value. And the other one over here is my y value. So all we have to do is actually 3 squared plus 4 squared. Following the color coding, 3 and 4. 3 and 4. Otherwise, then you calculate this, it's going to be 25, and this gives me 5. Alright, following up, CD, if you realize now, CD, the notion, just be a little bit careful, because if you recall, it's minus 4 and 2. So when you do the brackets, just be very careful. It's going to be minus 4 squared plus 2 square. If you were to use your calculator straight away, or if you write the additional step of square root 20, alright, this gives me the notion of 4.4721, and again round off to 3SF. Alright, do not leave an exact as square root 20. Square root 20 is not an exact value. Round off to 3SF. Alright, let's see whether I can do this. Okay, sorry for that. Okay, lastly, what happens is, okay, I want to find EF. EF even easier. You don't have to use Pythagoras. In fact, does anybody know, before I even do the answer, what is the magnitude of EF with the vector of 5, 0? Anybody wants to try? What is the magnitude of EF without even using Pythagoras? Okay, I'll give you all some time. What is the magnitude of EF? Alright, very good. So you realize over here, even if I use Pythagoras, it's going to be 5 square plus 0 square, which is square root of 25, which gives me 5. Essentially, you realize without the vertical component part, I'm just looking at the horizontal 5. So that's one way you can look at it, but if you realize, if you don't really want to, if it's too much for you, you can just use Pythagoras theorem as derived from the magnitude we have done just now. Alright, as we have done just now. So 5 square plus 0 square. Let me just rewrite it nicer. Alright, so I hope all these examples sort of make sense to everyone here. And I will check on you all with the notion of a bubble question. So Wx, alright, magnitude, this one you realize is sort of clear. You have 1 minute, alright, so I'll give you all some try. Launching a bubble launcher. 3, 2, 1, let's go. Okay, you have 1 minute. Take a look at this vector. How do I find the magnitude? Okay, I'm looking at Wx, so don't look at the wrong vector. I want Wx. And take note, which one should I use? What is the units I should use over here? Alright, very good. Some of you are doing good. Okay, take note, when I look over here, is it going to be cm or units over here, as I mentioned? So think about it. Alright, very good. Seems like all doing good. Okay, I'll just wait for a few more seconds. Perfect. Alright, you guys are doing so well. Okay, so again, I'm looking at Wx. It's just 6 units. Again, there's no negative units. And take note, cm, the question will say cm. But in terms of graphs, we always mention them as units unless otherwise. Okay, but you guys are doing so well. Perfect. Doing good. Okay, I'll just wait for a while for the bubble to end before I move on to the next one. Okay, very nice. So let's see. YZ. YZ is a little bit harder. Alright, so take note how we do this. Okay, you have 1 minute. Please take your time. Identify my vector properly. Launching the bubble launcher. In 3, 2, 1, and let me just check. Okay, in 3, 2, 1, and let's go. Okay, take note. Identify my vector properly. In this case, you will need your calculator, as you can see from the units. So take note. What is my vector initially? This and this vector over here. Alright, so take note of the calculation errors that may happen and how we solve. So first things first, you realize this question is very, very familiar, but what is this vector I have? And from there, how do we solve? Take note. When we calculate the magnitude, first thing is we need to know what my vector is. Alright, perfect. That's good. My first good response here. That's a good one. Alright, following up nicely. Just be careful with the brackets. I have one more. Perfect. I think you all guys get it. Okay, so in this case, let me just write minus 6 minus 7. Again, Pythagoras theorem tells me what? Working wise, just make sure you write the correct thing. It's going to be brackets. Remember your brackets, which I think you all got it. Perfect over here. And in this case, therefore, square root of 85. Alright, so when you write your working, remember to write as 5 significant figures at most, or at least, sorry, not at most, at least 5 significant figures before you cut it off to 9.22. Alright, so I guess there's no problem in magnitude over here. Good response over here. I think I can move on. You guys are doing so well. So good. You guys are doing so awesome. Alright, keep it up. Alright, keep it up over here. Alright, now let's see what we have. Okay, so different questions. Now the questions are going to be a little harder. Giving you the magnitude, how do we find the value? So giving you certain key things over here. So now certain variations. How do we find using what they give you using the vector? Using the vector and magnitude, how do you find certain things? In this case, values of m. But now, we know k is written as such. So first things first, they tell you the magnitude is 5, right? So what we do? Use the magnitude formula, which is m squared plus 3 squared. This gives you m squared plus 9. What does that tell us? This value over here is going to be 5. Where is it said? Over here. Once you have this down, what we can do? Simplify further. We are going to have m squared plus 9. Square both sides, you have 25. I hope this is clear. I have m squared is equals to 16. I want values. So that's why when you square root, in this case, I need a plus minus. Because we are not talking about length over here. We're just talking about the value of m. So the possibility when I square root, there's a notion of plus minus. And henceforth, m it's going to be 4 or m it's minus 4. Alright, so over here, we are just making use of what we have to find. Alright, so let me just get certain feedback again to make sure you all understand before I move on. Right, good to hear. Awesome, awesome. That's nice. Perfect over here. Okay, seems like all is going good. Just click your responses before I move on, alright? So that I can get your feedback. Okay, so I guess it's all green and maybe yellow, just waiting for the response, but that's a good thing to hear. Okay, so what happens? You all know the notion with the work example. Bubble question. Similar notion over here, just be careful with the notation. Launching the bubble launcher. Again, this one you have quite some time. Okay, I'll just wait for the feedback to come. I'm going to launch the bubble launcher in 3, in 2, in 1, and okay, I cannot launch my bubble launcher. Just give me a moment. Okay, I can do it now in 3, 2, 1. 3, 2, 1. Let's go. Alright, that's good to hear. Let's see what we have. Again, do not rush. You guys are doing good, so do not rush. Look at how I solved it just now. Okay, make use of what I have. Again, similar notion. Okay, so this is going to be 26. Okay, let me just hide my pen. So, 26.0. Alright, that's good. We're following up nicely. But just be very careful. Right, take your calculations well. And in this case, what will help is you can write down the vectors. It will help you a lot. H is negative 7n. And in this case, we know the other side. Okay, how do we find? Always write down the steps. Okay, you have 1 minute, roughly a bit more than 1 minute left. Okay, just be careful with the manipulation. Alright, just be very careful. Okay, just be careful with the manipulation. Over here, I believe it's the calculation errors that you may have. Okay, I would say there's a little error over there. Just be careful. Take note, the negative signs might have thrown some of you off. Last 30 seconds. Okay, I will need to go through this. Yeah, seems like there is a little error here. Okay, I guess most of you have your responses, so again, it might be certain calculation error. Let's see. Okay, so what happens? I have to find the magnitude of h. So magnitude of h over here is when you take the a squared plus b squared. Take note, your brackets are very, very important. So I hope you all realize the brackets are as such. And this is going to give me, take note, n squared plus 49. Now, what is this equals to? This is equals to 25. Then from there, you realize, oh, I square both sides. Okay, 25 squared is 4625. I subtract 49. Okay, check your working process. That's very important. I subtract 49. It's going to give me 576. Taking the square root of 576, guys. Plus minus 576. This is going to give me my two answers. 24 or minus 24. Okay, so that's why in this case. Okay, I'm glad that there's no answer for 1 and 2. That's good because remember square root. But I hope you all know where your mistakes are from. And again, I will just do the initiating feedback before I move on. Okay, just to get a response since like most of you are a little shy over here. And yes, and it's hard for y'all to type. Not saying y'all are shy. I don't want to have any like. I don't want to say anything too much on the other side. I just want to be neutral, but okay, looks like you guys are getting it. Okay, all good? Okay, perfect. Alright, so let's move on in terms of, I would say, a few more concepts that we need to go through. Okay, over here. Okay, now, when we talk about equal vectors, right? When we talk about equal vectors, one thing to take note, two vectors are in this case equal, to take note. Okay, if you follow your matrices calculations, two vectors are actually equal because one, they have the same magnitude, or in this case, they have the same direction. Okay, so equal. What do they mean to be equal? In this case, if I write them as column vectors, if I say AB is equal to CD, then essentially I'm really just writing AB is equal to CD, where I have my equations to be, both of them are equal, A, B, CD, A equals to C, B equals to D. This is very similar to your matrices where all the elements are equal, but instead of talking about elements, I am really just talking about the entries are being equal in their positions here. Alright, so let's zoom in and find out. Okay, another work example to how we utilize equal vectors. Essentially, given these two vectors and they are equal, how do I find? So, you realize over here, let's write down what we have. AB, A is equals to B. Take note, do not bold, write it in the curly brackets. I don't want you all to bold even though the curly are not given. If they write it in bold, write my curly lines over here. Okay, AB, so what I need to do, x plus 2y, 1 equals to 4x minus y. So you realize what happens, column vectors, two entries only, and usually two variables, simultaneous will come into play. So therefore, I have x plus 2y is equals to 4, x minus y is equals to 1. And we have the notion in this case of simultaneous equation. So what we can do, there are a few ways you can substitute and say y is equals to x minus 1, but you realize I can actually do elimination. 1 minus 2. So if I do 1 minus 2, I'm going to have 2y minus y, which gives me 3y equals to 3, y is equals to 1. Alright, and following up from there, that's where you have the substitution. So I can sub y equals to 1. In this case, you choose whichever equation you want, 1 or 2. But in this case, I'll sub it into 2 because there's no multiplication involved. Easier for me. So I have x minus 1 is equals to 1. X is equals to 2. So that's where I find the value of x is equals to 2. Y is equals to 1. Alright, so in this case, it's just equal and making use of simultaneous equations. Over here, I use elimination, but you can see that there are more than one way to do so. Alright, now let's launch the feedback again to check whether you all understand the notion before I go on, because it seems like you're a little shy. Okay, so it's like half-half. Okay, so what happens to clarify this, once they are equal, you equate them because they are equal. And after that, what happens? You can simultaneous your way. So maybe the unsure part is how I get y, right? So 1 minus 2, I'm going to have, okay, 1 minus 2, I'm going to have this. So when I subtract, maybe I just write it here. What's the notion of 1 minus 2? I hope this makes it a little clearer. Okay, I'm going to subtract. So in this case, x plus 2y minus x minus y over here, 4 and 1. Okay, these two are equal, like this. Okay, once I have this notion over here, you realize x minus x, they will subtract. 2 minus y is just going to be 2y, sorry, not minus y. And I have 4 minus 1. So therefore, you realize, hopefully you realize this equation links to this equation over here. And that's how I solve further. Alright, so regardless whether subtraction, whether elimination or substitution, you will essentially get to this equation over here. Again, methods to understand elimination, just a recap, coefficients are the same, either in x or y, subtract, or if you realize they are not factors of each other, we substitute. Okay, it comes with practice, and that's where I have bubble question number 9. Again, P equals to Q. How do I solve it? Launching the bubble launcher, again in 3, 2, 1. Let's go. Okay, we are almost there. Okay, this is actually the second last concept that we want to go through. So let's see what we have over here. Okay, give yourself some time. So again, first step, what we do, we are actually going to write down what we have. Okay, take some time. I have P and Q. So this is 2m, this is 3n, this is equals to m plus 3, this is equals to n minus 4. And then how do we solve? Alright, perfect. I got my first answer down. That's good, that's good. Okay, in fact, I would say this simultaneous equation, it's a little much more simpler to solve. But don't worry, I'll give you all some try. A little bit more time to solve. Okay, 1 more minute, that's good to see. Alright, that's good, that's good. Okay, so what will I have if I have two vectors that are equal like this? What should I do? Okay, just wait a little while more. Okay, so I hope you all realize if I have two vectors that are equal, what will I have? Okay, 40 more seconds. Alright, perfect response. That's good, that's good. Okay, that's a good thing to see. Okay, so I guess I can carry on. Okay. So what happens if I have two equations like this, 2m equals to m plus 3? I hope you all realize that this is solved as m is equals to 3. And in this case, I have 3n is equals to n minus 4. And then I can solve it from there. So elimination, simplification, 2n is equals to minus 4. N is equals to minus 2. Getting the answers, you realize answer is number 4. Right, that's the notion over there. Alright, that's the thing that we have. Okay, I hope you guys did it, and yeah, let's move on. Now, last one, 0 vector. As the name suggests, you have 0 matrix, in this case where all the entries are 0. Over here, I'm just talking about a vector. So matrix, everything is 0. Vector, everything else is 0, is essentially a 0, 0. Everything is 0, 0, 0. And in this case, if you were to take note, if you were to use your Pythagoras theorem, or even you don't even need Pythagoras theorem because everything is 0. 0 square plus 0 square is 0 square. If you add them, if you take the square root of 0, is 0. So 0 magnitude. And it has no directions because there is nothing to draw over there. But take note, even though there's nothing to draw, there's no line. Important note over here, guys. Important note. Not a scalar. So we don't just write 0. We say it's 0x, 0y, but it is not a scalar. It's just telling us no magnitude, no direction. Okay? Okay, it's not 0 direction, sorry for that. It's no direction. Okay? Very careful. Okay? Even though it's 0, we cannot say it's a scalar. It just tells us there's no x, no y, but there's still some form of direction. So therefore, it is still a vector. Okay? One type of question that can come with 0 vectors. Okay? Essentially, just like what happens, they're equal. Okay, even given that this is a 0 vector, okay, this is quite straightforward. 6 plus x, 0 equals to 0. Again, don't color code. It's just everything is 0, 0. Find the value of x. Essentially, solving it equals and equal. Alright, so this one I think is quite straightforward. I think you guys can do it. I don't. There's no need for the feedback from you all. Let's ace this. Last one in 3, 2, 1. Okay, 30 seconds should be okay. Let's go. Let's see how we do it. Okay, one type of question with 0 vectors. Let's see how we do it, guys. Let's see how we do it. Alright, as you can see, very nice. Again, write down the equation first if it helps. 0, 0. Otherwise, we can solve it. Alright, that's good. Okay, seems like you got it. Let me just finish everything up. 3 minus y is equals to 0. Y is equals to 3. Nothing fanciful over here. Okay, when they are equal. And in fact, with this, we are actually done for today. So, what we have learned, essentially, it is really an introduction. Okay, what is a vector? How do we represent a vector? And how do we see in a Cartesian plane? Okay, it's only going to be x and y. There's no x, y, c, a, b, c, d, e, f, g. No, only x and y. Right? So, don't worry about that. how long is a vector, and how do we account the questions if the vectors are equal and maybe even zero vectors, even though it's a little rare. Alright, that's actually it for today. Okay, so thank you everyone for being here. There's a little Q&A which I don't think y'all will need, but if you really need to be part of the Q&A, I will answer some of questions if needed. Otherwise, I'll see you all next week. Take care, stay safe. This is Teacher Jason signing off. Bye bye.